Hello children, welcome to AIMS India's online classes. In today's video from mathematics subject, algebraic expressions topic we are going to discuss. So already we have learned some concepts children up to division by polynomial by another polynomial. Up to this topic already completed. So let's start with general form of division algorithm. General form of division algorithm. So let us consider two polynomials. So one is p of x, another one is g of x, such that g of x is not equal to 0. P of x is the polynomial name children, and g of x is the another polynomial, where g of x is not equal to 0. It is not equal to, g of x is not equal to 0, and p of x is the dividend. P of x is the dividend, or p of x is the expression which is to be divided, and g of x is the divider. G of x is the divider. If we have two polynomials like this is the dividend, this is the divisor, and the divisor is not equal to 0. So then q of x will be the coefficient and r of x will be the remainder. R of x will be the remainder. According to division algorithm, division rule, we can write this division process as dividend p of x equal to divisor g of x into quotient q of x plus remainder r of x. We can write like this. So according to division rule, and degree of r of x, the remainder, degree of remainder always to be less than degree of the divisor. Degree of the divisor. So this is a general form of division algorithm. Now let's solve this problem using the division algorithm. So let's divide x cube minus 9x square plus 10x minus 5. This is to be divided. We can take it as p of x by x minus 3. We can take it as g of x. Now p of x to be divided by g of x. So let's write p of x in the brackets, and on the left hand side of the bracket, let's take g of x. Now with first term of divisor, we have to divide first term of dividend. First term of divisor x, dividend x cube, means dividend x cube by x. 1x cancel, x square will remain. This will become the first term in the quotient. If we divide first term of the dividend with first term of the divisor, we will get first term of the quotient. But with that, we have to multiply all terms of the divisor, x square into x cube, to be written below the like terms, and x square into minus 3x square. Next, continuation. We have to subtract while doing division. Plus x cube minus x cube cancel. Minus 9 plus 3 x square equal to minus 6 whole x square. We can carry down the next term, which is plus 10x. Now, up to here, one part is completed. Now what we have to do with this? In the remainder, whatever first term we have got, that is to be divided with the first term of the divisor, means minus 6x square by x. If we divide, minus will come, 1x cancel, 6x will come. So this will be the second term of the quotient. But with that, all terms to be multiplied. Minus 6x into x, minus 6x square, minus into minus plus 6 3 times 18x. We have to change the signs. It will become plus, it will become minus. minus 6x square plus 6x square cancel. 10x minus 18x equal to minus 8x. So up to this part completed. Next we can carry down the next term minus 5. Now this is the remainder. In this first term minus 8x to be divided by first term of the divisor. First term of the divisor x. Because every time whatever remainder we are getting, it will become the dividend. Now this is the remainder, but this will become the dividend. Now this is the remainder, this will become the dividend. So first we have divided x cube and we got first term of quotient. Next we have divided minus 6x square, we have got minus 6x. Next we have divided minus 8x, we have got minus 8. So minus 8 into x, minus 8x, minus 8 into minus 3, plus 24, signs to be changed, plus minus, minus 8x plus 8x, cancel, minus 5 minus 24, minus 29. Now, the degree of minus 29 is 0 because it's constant term, but the degree of divisor is 1. So, degree of remainder is less than degree of divisor. So, division process will stop here. Division process will stop here. So, we got quotient q of x, x square minus 6x minus 8, and remainder r of x. And this is dividend p of x, and this is divisor g of x. Whether it is true or not, we can check it by verification method. If we check it, p of x into g of x, g of x, the rule is p of x equal to g of x into q of x plus r of x. So this is g of x into q of x plus r of x. If you multiply all these terms, it will be equal to this p of x. So our answer is correct. It is verified. The verification process you can do it, children. You can multiply and you can check it, cross check it. If you want to verify, we can verify by this process. So once again, children, let me explain the division process. So we have to divide this polynomial by this polynomial. This polynomial, it will become the dividend. Let it be p of x, and this polynomial, it will become the divisor. Let it be g of x. How to divide in division according to division algorithm means first term of dividend to be divided by first term of divisor. So x cube by x, 1x cancel, it will become x square, and this will be the first term of quotient. After that, we have to multiply with this all terms of divisor, x square into x, x cube, x square into minus 3x square. Next signs will change. We will get minus 6x square. We will carry down next term. Now we have to divide. Now this is the remainder, but it will become the dividend. Now in the dividend first term, minus 6x square with to be divided with the divisor first term x. So minus 6x will come. This will become second term of quotient. Again with this we have to multiply all terms. Symbols change. Minus 8x will come. Next term we have to carry down. This is the remainder. This will become dividend. And in this first term, minus 8x, we have to divide with the first term of divisor. So minus 8 will come. This will become third term of the quotient. Third term of the quotient. We have to multiply all the terms. Symbols change. Minus 29 will remain. No terms to carry down. And degree of remainder. Degree of remainder is less than degree of divisor. So we can stop the division process. So this is the way of doing division using long division method, children, and we can verify the answer. Next, So next we have identity. So equations and identities are different. So equations are only true for any particular value of variable, but identities are true for all values of variables. Suppose x plus 3 equal to 7. Is it a identity or equation? In the place of x, if we keep plus 4, then only it will be true. If we keep other values like 1, then it will be false. So this equation, it is true only for some values of variable, but not for all values of variables. So this is just an equation. This is just an equation. So whereas you have formula like this, or you have equation like this. So a plus b whole square equal to a square plus 2ab plus b square. We have equation like this. Let's take a value 1, b value 2 and cross check the answers. A value 1, 2. 1 plus 2 whole square. 1 plus 2, 3 whole square. 9. Left hand 9 is the LHS part. What about RHS? RHS a square, 1 square, b square, 2 square, 2ab, 2 into 1 into 2. 1 square 1, 2 square 4, 2 to the 4 plus 1. So 2 times 4, 1, 4 into 1, 4, 1 plus 4 equal to 9. RHS means for 1, 2 values it is true. LHS equal to RHS. Let's try with another values. Now take 2, 3. In the place of A, let's take 2. In the place of B, let's take 3. 2, 3. So 2 plus 3 whole square. 2 plus 3 means 5 square. 5 square means 25. LHS 25. What about RHS? 2 square plus 3 square plus 2 into 3. 2 square is 4. 3 square is 9. 2 times 4. 4 3 times 12. 4 plus 9. 13. 13 plus 12. 25. So LHS equal to RHS. Equation is true for other two values. Now let's take one minus value. 1 minus 1. Let's take 1 minus 1. So A plus B. 1 minus 1 whole square. 1 minus 1 whole square. 1 minus 1 means 0. 0 square, which is equal to 0. Left hand side 0. Right hand side 1 square minus 1 whole square, 2 into 1 into minus 1. So 1 square is 1, minus 1 whole square also will become 1 because even exponent, plus minus into plus minus 2 into 1 into 1, 2. 1 plus 1, 2 minus 2, which is equal to 0. 2 minus 2, which is equal to 0. So for negative integers also it is correct. Let's take one fraction. 1 by 2 plus 1 by 4. 1 by 2 plus 1 by 4. 1 by 2 plus 1 by 4 whole square. 2, 4 LCM how much? 4. 2 times 4, 2, 1 is 2. 4, 1 is 4. 2 plus 1 by 4 whole square. 2 plus 1, 3 by 4 whole square. 3 square is 9, 4 square is 16. 9 by 16. Now, A, 1 by 2 whole square plus 1 by 4 whole square plus 2 into 1 by 2 into 1 by 4. 1 by 2 into 1 by 4. 1 by 2 whole square, 1 by 4. 1 by 4 whole square, 1 by 16. 2 gets cancelled. 1 by 4 will remain. What is the LCM? 4 is the LCM. 4 into 4, 1 is 4. Sorry. LCM. 16 is the LCM. 4 times 16, 4, 1 is 4. 16, 1 times 16, 1 is 1. 4 times 16, 4, 1 is 4. So it is also equal to 9 by 16. So it is true for positive values, negative values, rational numbers, We can take root values also. It will be always true. Means for any variable it is true. So this is called an identity. An equation which is true for all values of variables is called as an identity. So these identities are very, very important, children. So throughout mathematics subject, in any class, in any chapter, we will make use of these identities. So you have to by heart these identities, children, and you have to remember these identities so that it will be easy for you in solving the problems. A plus B whole square. So first term square, second term square, 2 into first term into second term plus 2ab. This is the formula. Suppose if you have a minus b whole square, first term square, second term square, minus 2ab. If you have plus b whole square, plus 2ab will come. Minus, if you have minus in the middle, minus 2ab will come. That is the difference. A square minus b square. If you have individual squares and their subtraction, it is equal to product of a plus b into a minus b. Next, x plus a into x minus b. So x into x square will come, a into b, ab will come, but in the middle, x into b, xb, x into a, xa. Two x terms will be there. So we can take x as common, x of a plus b we can write. So actually binomial plus binomial, 4 terms should come in the multiplication, but x into b, a into x is common in 2 terms, so we can take x common. Suppose if you have 1 term plus 1 term minus, 1 term plus 1 term minus, or plus a minus b, then the middle term will become a minus b. Or if you have both minus, then minus of x into a plus b will come. You can observe here, children. So here x square term is same, plus ab is same, here plus ab is same, but here in the middle, when one is having minus, when both are plus, last term is plus, when both are minus, last term is minus. But only when one term is minus, this last term will be minus. And if second term is minus, here middle minus will come. If both are minuses, so then minus x into x term, total x term will become negative. Or if first one is for a, if you have minus symbol, then also last term will become minus, and here b minus a will come. If in the factors we have minus in the second factor, then a minus b will come. If we have minus in the first factor, b minus a will come. That we have to remember. These four, this fourth one, fifth one, sixth one, and seventh one belongs to one category, children. You have to remember them separately. Next, eighth one, a plus b plus c whole square. 3 terms, sum of 3 terms and their square. So a square plus b square plus c square plus 2 into a product of first 2 terms. Next 2 into product of second and third. Next 2 into product of 1 and 3. Total 6 terms will be there. Suppose in the LHS part, for the third term if you have minus, for C if you have minus, there will be no change in the first 3 terms. In the product of 1 and 2 also no change, but product of 2 and 3 will become minus, product of 1 and 3 will become minus. Means the terms which are having that term will become minus. Suppose if we have minus for second term, then first 3 terms common, no change. The product of 1, 2 in that second term is there, it will become minus. The product of 2, 3 in that second term is involved, it will become minus. The product of 1, 3, no second term involved, it will be positive. Next children, if both are minuses, if minus is there for two terms, minus is there for two terms, then first three terms, no change. Product of 1 and 2, only one minus is there, it will become minus. Product of 2, 3, for two terms minus is there, it will become plus. Product of 1, 3, only for one term minus is there, it will become minus. So this 9, 10, 11 are one group children. You have to, 8, 9, 10, 11 are one group. You have to remember them separately. Next children, we have a plus b whole cube formula. It can be written as, so a cube plus 3a square b plus 3ab square plus b cube. Or from these two terms, we can take 3ab common, then here a will remain, here b will remain. So we can write it as a cube plus b cube plus 3ab into a plus b. Suppose if you have minus b cube, so here a cube minus 3a square b, here only b1 is there, b power 1 is there, for that minus symbol will come. Here b square is there, even exponent, for that plus will come. And last term, actually here b1 odd exponent, for that minus will come. B square even exponent, plus will come. B cube odd exponent, minus will come. We can also write in this way, all with all minuses. Instead of all plus symbols, we can keep minus. A cube minus b cube minus 3ab into a minus b. Like that also we can write. These two are one group children. You have to remember them separately. So these are the identities which to be remembered. This 1, 2, one group, this one separate, this next 3, and this one group, next 4 one group, next 2 one group. You have to remember them separately, and you have to by heart them. You have to remember them in reverse process also, so that they will be useful in solving the mathematical calculations. So let's revise the CDF points children. So concepts, definitions, formulae from this chapter, whatever we have learned so far. So the numerical or literal or their combination by operation of multiplication is called a term, like 3x. Combination of literal and numeral and their product will be considered as a term. So terms which contain same literal factors are called like terms or similar terms, like 3x, 4x. Same literal factor, xx is there, so they are called like terms or similar terms. So if a is any literal and n is any natural number, then a power n equal to a into multiply n times, and a power n is called exponential form. Instead of repeating the same number, multiplying the same number repeatedly n times, we can write it as a power n, which is called exponential form. In a power n, a is called the base, which is to be multiplied, and n is called the exponent, which denotes number of times the base to be multiplied. So here n is also called exponent, power, or index. So when numbers and literals are multiplied to form a product, then each quantity is called factor of the product. Suppose we have 6x square y for this term. For this term, 6 is a factor, x square is a factor, y is a factor, because all of them can divide the product individually. So they are called, each individual quantity is called a factor. Next, a combination of literals and numbers connected by symbols or operations like plus and minus is called algebraic expression. If you multiply, we will get a term. If you multiply, we will get a term. If we combine them with plus or minus, then combination of terms will become an algebraic expression. So, an expression containing one or more terms with positive powers. If in all the terms, if the powers are positive, then it is called a polynomial. It is called a polynomial. So, if there is negative exponent, it is not a polynomial. And the sum of powers in each of its variable is called degree of the monomial. Suppose we have 6x square y. Here x power is 2, y power is 1. The sum of all powers 2 plus 1 is 3. This is the degree of the monomial. This is the degree of the monomial. Suppose in an expression we have terms like this. Here the degree is 3 of this monomial. Here it is 5. Here it is 3. We have different degrees for different monomials. But in all the monomials, the highest degree is 5. That is called degree of the expression. The highest power of all the terms in an expression is called degree of expression. So, combining the coefficients of like terms of an expression through addition or subtraction is called simplification of algebraic expression. So, in the given algebraic expression, if like terms are there, if we combine them and if we make them into one term, then it is called simplification. Simplification. If no two terms are alike or same in the expression, then it is said to be in simplified form. Simplified form. If all the terms exponents are in descending order, then it is said to be in standard form. So, difference between two like terms is again a like term with a numerical coefficient equal to difference between the numerical coefficient of two like terms. So, 6x minus 4x is 2x, which is a like term of these two, and the coefficient 2 is difference of these two coefficients, 6 minus 4. Next one, how to get additive inverse means additive inverse of a number we will get by simply changing its sign, or additive inverse is called negative of that number. So, sum of number and its additive inverse is always 0. So, additive inverse of expression means it will be obtained by replacing each term by its additive inverse, or by changing each term's sign, we will get the additive inverse. So, the sum of expression additive inverse is always 0. So, product of two factors with the like signs, so plus into plus will become plus, minus into minus will become plus, or product of different signs, plus into minus or minus into plus will become minus. Next, division algorithm is there, that is dividend equal to divisor into quotient plus remainder, or division rule. So, when a polynomial p of x is divided by another polynomial g of x, where g of x is not equal to 0, we get quotient q of x and remainder r of x, whose degree is less than degree of divisor g of x. If the degree of divisor is greater than degree of dividend, then the quotient is 0. If the degree of divisor is x to the power of 4 and degree of dividend is x square plus 2x, means 2, as the degree of divisor is more than the dividend, it cannot divide it. It cannot divide it. So, we have to divide with 0, quotient will become 0 and the remainder will become the dividend. Remainder will become the dividend. So identity means equality which is true for all values of variables. Equation means true for only some values of variables. And these are the examples of identities. But we have to remember all the identities which were already we have discussed. Only some identities mentioned here. So children, problems we can solve in our next video. So that's all for today, children. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. You can visit our website, children, aimstoday.in, for information regarding online classes, quizzes, worksheets, activities, English class, and coding skills. Thank you, children. Have a good day.